Hiya! So in this video, we're going to be looking at the cumulative distribution function in terms of discrete distributions. So in this case, let's look at an example. I think in this example is kind of going to be the best way to kind of see what they look like, right? To see why it's not necessarily continuous. Remember, the distribution function being continuous, the cumulative distribution function being continuous tells us whether or not our distribution is continuous or not. So here we're gonna have an unfair coin. Oops. We have yeah, green's okay. We have an unfair coin, which is heads 2/3 of the time and tails 1/3 of the time. And we let x be the flip of the coin, so either heads or tails. And we let ix be the indicator function for x. In other words, I of x is equal to 1 if we flip a heads, and I of x is equal to 0 if we flip a tails. So what we have is this equality, right? P of ix is equal to 1 if P of x is equal to heads, which is equal to 1, which is equal to 2/3. Now, how do we draw this the probability for this? Well, generally the way we're going to draw this probability is like this, right? So this is for I of x. So this is I sub x, right? So if I sub x is equal to 0, I think I did my graphs wrong. This should be, did I write 2/3? Yeah, this is wrong. This should be 1/3. You know, okay. We're gonna change this slightly. We're gonna make this 1/3, this 2/3. I'll fix this in your thingy. So 1/3. Heads is 1/3. Tails is 2/3. Okay, so I have I of x. The chance that x gives me 0, so I of x is equal to 0, we have a 2/3 chance, right? So this is what this is saying. 2/3 of the time, we'll get tails. For 1, I of x is equal to 1, we have 1/3. So this is our chance of getting heads. One-thirds. So when we're doing the cumulative distribution function, what we have to do is, remember, we have to look at P of x less than or equal to x. So here, what we'll do is we'll look at things over time. So if anything below x is equal to 0, everything here is basically nothing, right? So there's nothingness here. Because we don't have anything happen. And then at x equals 0, we suddenly have a spike, right? We have 2/3. So here we have 2/3, and then this continues. And the reason this continues is because really here what we're looking at, P is x is less than or equal to x. So 1/2, for example, what's the probability that x is less than or equal to 1/2? Well, 0 is less than or equal to 1/2, and so we're always going to have to consider that 2/3. And so that's why we kind of have this. And then at 1, what happens at 1? Well, at 1 we spike up again. Because now we have to add the 1/3. So here we have 1/3. Here we have 2/3. And this kind of keeps going for the rest of life. That's it. And this bottom part also goes the rest of life, but the other way. And that's because if you think about this, what we have is if I have x less than or equal to x, if I do x less than or equal to 4, for example, well, both 1 and 0 are below 4. So I need to add both of those probabilities, right? And so that's why we get 1. So normally when we're looking at cumulative distribution functions, we start off at 0 and at minus infinity, we end up at 1 at positive infinity. So in this case, it's kind of easy to see that this is not continuous, right? We have discontinuity points, right? It's a step function. And usually discrete distributions are step functions. This also shows why we can't just replace less than or equal to with less than, right? If I had less than x, so for example here, P of x less than or equal to 0, well, this is 2/3, but P of x less than 0 is equal to 0. right? So they're inherently different. So here we kind of have this, I think normally we do a little circle here, and then here we do a closed circle. Here's an open circle, and here's a closed circle, yeah? So you can inherently see that they're not the same. So that's the discrete case. So we'll stop here. And in the next video, we'll talk about the continuous case. So I'll see you then.